Okay, quick intro to this video. So I have a rather wide-ranging interests in on with YouTube content, and one of those is, of course, science fiction, futurism, that type of thing. And I found this guy's channel, John Michael Goldier. He's he's science fiction writer, like a hard science fiction. But he's just a curious guy. He's got a real soothing voice, and this is one of his earliest videos. So he's interested in like weird, anomalous things that are actually out there and being looked at and talked about by astronomers. So weird, but like, you know, not superstitious weird. So this star, there's a few stars that are weird, but the one in particular, title of this video, Plutonium in a Star, an Alien Nuclear Waste Dump, which sounds, the title sounds like it could be from any kind of fanciful, you know, what's the word, folklore UFO stuff, but trust me, it's not.
I often give updates on strange stars on this channel that have no ready explanations.
Also, I had to speed up because he speaks quite slowly and calmly, and it's too slow.
Just Boyajian star and the possibility that it might indicate alien activity. But there is another star that may also be an indicator of an alien civilization that's currently making the rounds on several science blogs, links in the description below. And it may even be a better candidate for being a potential detection of alien life than Boyajian star.
So before we get to this particular star, there's actually a few of them. And the detection, what we're talking about here is the Kepler spacecraft. So the Kepler spacecraft has what they call a photometer, a very, very sensitive instrument that measures the precise amount of like light, so photons coming from a bunch of stars. Like I believe it scanned like 10,000 stars over and over again. And so when you're measuring the actual quantity of light, rather than like making it a image, you can pick up little dips in the brightness. And the idea, of course, is if a planet is moving between us and the star, and making there's a word for it, oculate, I believe. Anyway, not a cult. Anyway, like a miniature eclipse. You know, it's gonna block some of the light in a predictable way. In fact, Kepler has found like, I think, over 5,000 planets, but it also found some weird shit that to this day is very hard to explain.
The difference between the two is that while KIC 8462852's strange dimming events could indicate alien megastructures blocking light from the star, that's probably not the case. See the other videos dedicated to that star on this channel. It's much more likely that what we're actually seeing is an incredibly rare natural event, such as the star recently having ingested a planet. But while the explanation for Boyajian star is going to be interesting, whatever.
So that star was recording like real fucking weird dips in light, and there's the instruments also measure other factors in the light, like Doppler shift, whether the light's being filtered and so forth, and whatever it was going in front of this other star, Boyajian star. It didn't behave like normal smoke, because smoke would absorb certain wavelengths and let others through, and would heat up and emit infrared radiation, none of which was seen. And the light dips were just highly erratic. People were mathematically modeling it, and some scientists, an actual scientist, like, you know, not a layman, modeled it through and said that the light dips match like triangular objects going through space and partially covering up the star. It was kind of a joke. He's just like, you know, mathematical models can come up with a whole bunch of things that fit the data that aren't real. So anyway,
it might be, it's probably going to be a variant of something we've seen before or expected to be going on in the universe, and won't require a rethink of a whole area of science. The circumstances of this other star, however, are very different. Now, I tend to try to get the naming of the celestial objects I talk about on this channel as correct.
Yeah, and it's people are wondering why don't we know more about this? Are people trying to hide the story? Well, first of all, one astronomer did this research in Australia, and he has a real, like, fucking one of those weird ass Polish names that nobody can spell or pronounce or remember how to spell. So that's partially why it's not you know, so mainstream. And nobody's questioned his data. Nobody's debunked it. Nobody's gone and measured it again because Southern Hemisphere. It's one of those things. And this guy John Michael Goldier has been doing this for a while, and he now does another podcast with young astronomers who are free thinkers, and he's getting one of the guys has a YouTube channel called Cool Worlds, and he's even spoken to Joe Rogan and stuff. And they're trying to raise awareness to go back and have another look, figure out what the fuck's going on. So let's get to why this is probably the weirdest fucking thing I've ever heard of a star from real hard science that has no explanation really apart from it being artificial that we know of.
Correct as I can get them, or I simply default to the official catalog numbers if there's ambiguity surrounding it. After all, KIC 8462852 is also known as the WTF star, Tabby star, Boyajian star, the alien megastructure star, and so on, though it seems to be settling on Boyajian star as a matter of giving proper scientific naming credit to the lead investigator. But with this star, I fall completely short. This star does have an accepted name, and I apologize to any Polish speakers in the audience in advance. The pronunciation for this star is all over the place on the internet, and the best I could do was ask a person I know that speaks a bit of Polish. I'm told that something close to the proper pronunciation for this star is Przybylski's star.
Przybylski's.
I'm sure I got that wrong. Polish words are about as tough to pronounce as it gets for native English speakers, but at least I didn't chicken out and tried. But for the sake of clarity, I will run and hide for the rest of the video and use the catalog name for the star, which is HD101065. But we could also...
I worked for a Polish actuarian accountant who owned a vodka Polish food bar in Paran, Borscht Vodka and Tears. And man, this guy had the most German deadpan kind of humorless lack of humor. He was cool as, but he had lethal strength, bootleg vodka and stuff. Yeah, I don't think I've ever been more alcohol poisoned at a job in my life.
Call this star the plutonium star because it apparently contains it, along with a bunch of other ultra heavy elements that are both.
Okay, so plutonium has a reasonably short half-life, 100,000 years, I believe, maybe 10 million for certain isotopes. Plutonium doesn't exist naturally on Earth at all. Uranium is the heaviest radioactive element because its half-life is long enough that it's still around. I think the uranium-238 its half-life is in the billions of years. So yeah, plutonium doesn't exist in nature. Even if it was produced in the past by some supernova colliding neutron star type event, it would have all decayed by now. So finding plutonium anywhere in large amounts is already fucking eyebrow raising.
Highly unstable and very short-lived. Those should not be there and can mean one of three things. Elements exist that we did not really expect to see in nature. The detection of ultra-heavy elements is a mistake, or aliens made them artificially and dumped them into the star. Now, these elements are at the very end of the periodic table, a mysterious place where we know comparatively little about the chemistry of the transuranic elements, and some of them have only relatively recently been synthesized artificially in the lab. Outside the lab, we see these elements so far nowhere in the universe other than this type of weird star. In fact, these heavy elements are so far up the table that some physicists and chemists are skeptical that they can exist in nature and can only be artificially synthesized. Given that they seem present in the star means that we either need to rethink the mechanisms for which heavy elements can be produced in nature, or we must consider the possibility that aliens put them there. HD1.
Okay, so the way when they say plutonium was detected in the star, this is spectroscopy. Which is insanely powerful. Spectroscopy is literally you take starlight, put it through a prism or a diffraction grating, same thing. So you get the spectrum, spread all the light out into a rainbow and beyond into light we can't see. And there is a awesome quirk of nature where different elements emit different bands of light from electrons jumping up and down different orbitals, and these are very distinct. So in the world of quantum physics, electrons exist in a standing wave sort of shell around nucleuses of atoms, and the rules are real weird and stuff, but the electron is in one standing wave buzzing around, and then it flicks to another one that's higher up in energy scale. So if you excite any element, like vaporize it and put some electricity through it, you can get it to emit light, like a neon tube. And then if you put that through a spectrum, you get a bunch of different lines in different places, and every element is unique. Pretty fucking convenient. So the reverse is true as well. Stars emit what they call black body radiation. So if you heat something up, it will get hotter and hotter, and it will start emitting infrared, and then it will keep emitting infrared, but it will start emitting soft red light, then white hot. And stars, of course, are hot enough that they can get blue and they emit lots of X-rays. But black body radiation is like a background smooth spectrum of light shining through, and the atmospheres of stars have the same elements as the interior. Some stars fully convect, like a soup, and the atoms at the very outside of the star's atmosphere are relatively cool, and they absorb light. And of course, elements absorb the same distinct lines of light that they emit. So the genius of scientists over hundreds of years is to take individual elements, excite them in a vacuum chamber with electricity, fingerprint them, and they have libraries of every element, and even molecules, but that's more complicated. But so we can look at starlight with modern instruments, and we can detect, like, I think one atom of a different element for every 10 million regular hydrogen atoms, or something crazy. So, but make no mistake, the amount of plutonium that has to be in a star's atmosphere for it to be detected at all from Earth still has to be a metric fuck ton. Not the few kilograms that we've made, over 50 years in nuclear reactor. So he's just started talking about transuranium elements. So there's theories in quantum physics that super heavy elements might exist way higher up that are actually stable. We haven't found any hint of that yet, but I'll mention that because you'll see why. We'll go back to the video.
01065 is chemically weird in many ways. First studied in 1961 by the aforementioned Polish-Australian scientist whose name is in the title of the video. Apologies to him, and his original paper is also listed in the description. The star features very low iron and nickel, but comparatively high amounts of heavy elements like thorium and uranium. Now, these do occur in nature, so it's really the ratios that are strange. But it also seems to contain actinide elements heavier than uranium that don't make a whole lot of sense.
Okay, so the actinides are a group of elements beyond uranium that are chemically in the actinide groups. So the periodic table is periodic, and there's a whole row of chemicals with similar chemistry below it that aren't radioactive. So this is like the next row, and there's a whole bunch of them. And nuclear reactors generate a lot of these transuranium, like heavy elements, and a lot of them have really, really short half-lives. Plutonium has a longer one. I mean, you can actually hold a lump of plutonium with just like a decent thick, maybe a lead-lined glove. Although some isotopes of plutonium are so hot that a grapefruit-sized lump would glow dull red hot just from the raw output of radiation. So I don't think you'd want to hold that one. But yeah, it wasn't just plutonium in the star.
For being there. These include, reportedly in ascending order, americium, curium, berkelium. Only about 1 gram of that element has ever been created on Earth. Californium and einsteinium. There's some ambiguity as to whether those are really there, only more study will clear that up. But also present are the lighter but still radioactive elements technetium, which has no stable isotopes and is extremely rare in nature, but maybe...
So technetium is an oddball and shouldn't be in this bloody star as well. Technetium's lower down the periodic table, but for some reason that's beyond my knowledge level, there are no stable isotopes of it at all. I think there's certain magic, they call them magic numbers of protons and neutrons in the nucleus that are more or less stable. So for whatever reason, technetium technetium is like a blank spot in the lower scales of the periodic table. And for a long time, when the early detectives were building up the periodic table, they found gaps with unknown elements because they could predict where the elements should be based on common chemistry. And technetium was never found. And it was only later with the discovery of radioactivity that they made some of the short-lived isotopes in the lab. So technetium shouldn't be in this bloody star either.
Related to the presence of the uranium, and promethium, which also has only radioactive isotopes, plus lots of other rare elements that you don't hear much about. Yet HD 101065 has them in comparative abundance, apparently and possibly so. In fact, as Jason Wright of Pennsylvania State University notes in his blog, this star has more praseodymium, how often do you hear about that element, than iron? This could be somewhat elusive.
I mean, that's insane. But he's about to go on to say that not all stars fully convect. Our sun has roughly the same proportions, or almost exactly the same proportions of elements as we do, with the exception of hydrogen that we lost from our planet. And Jupiter is the same as well. So the sun isn't just a pristine ball of hydrogen glowing. It's actually reasonably dirty because the hydrogen comes from the beginning of the universe, but there's been a lot of generations of short-lived stars pumping out heavy elements when they go boom boom, and iron is the last element that can be nucleus that can partake in nuclear fusion and generate more energy. Iron's the brick wall. So when a star's gearing up to go supernova, the core starts to build up iron from literal nucleosynthesis from hydrogen all the way up. And then it hits a wall, and eventually the gravity wins out because the iron can't produce fusion heat. And that iron core, which is sometimes bigger than the Earth, quite a lot bigger, collapses under its own weight and shrinks from the size of the Earth down to either a black hole, which is 10 kilometers in diameter, fucking whirlpool to another universe or whatever, or more commonly is a neutron star, which is like the last stable matter that we know of before a black hole. And the only thing holding up a neutron star is quantum forces not wanting gravity to win. But the center of a massive star, just as it goes supernova, that core, larger than the Earth, collapses at half the speed of light under its own gravity. And if it ends up being a neutron star, it stops collapsing when it gets to about 10 kilometers in diameter. I mean, think about that. And of course, what happens is the rest of the mass of the gas on top of that iron core, the rest of the star, which has onion ring layers of fusion from other elements, well, then there's now suddenly a Earth-sized void right in the middle of this object. So the gravity of all that mass screams in under its own weight, and basically it's like one of those sonic cavities in the water when I've seen if there's little fish that flick the water so hard with their tails that they produce a flash of light because they create a cavity in the water, and then the water slams back with such force that it generates a flash of light. But yeah, the literal explosive power of a supernova comes from the entire star filling that Earth-sized void when the core collapses and then rebounding. And because the gravitational potential energy of that outer layer turns into kinetic energy as it smashes in and then just blows itself back apart because that extra energy allows for fusion at higher levels. And the final supernova pumps out all of these heavy elements. There's other ways too. You can have two neutron stars smash into each other, and theories actually say that certain elements like gold are probably exclusively made by smashing neutron stars. So these heavy elements shouldn't be in this quantity that are normal. Certainly not in a higher proportion than iron.
However, Dr. Wright details how those elements might get concentrated in the star's atmosphere in layers due to the very strong, somewhat mysteriously so, magnetic fields of this type of peculiar star. I highly recommend to those wishing to dig deeper into this story, check out his blog and the other related materials, which I have included links and citations for in the description below. So how do all of these strange elements end up in a star's upper atmosphere? A 2008 paper by Vera Gopka and colleagues, link below, details that they might be produced by a nearby neutron star. Trouble is, HD 101065 does not appear to have a nearby neutron star. Strike that explanation. The next explanation has to do with the periodic table. Now here is where we get into scientific rethink territory. The heavy actinide elements do not like to exist. The nuclei of these atoms are truly huge and essentially fall apart or decay into more stable atoms, releasing energy along the way. This allows you to do interesting things, such as easily split atoms of uranium. This yields nuclear energy, but also unfortunately allows for the creation of nuclear weaponry. But above the unstable actinides, there is hypothesized to be what is called the island of stability, where there could...
So yeah, the island of stability. Now, a lot of people are aware of Bob Lazar. In my opinion, the most credible crashed UFO engineering folklore type story. And he famously said that the anti-gravity, antimatter drive that powered the whole thing ran on a super heavy element that was stable, and he said it was an isotope of element 115. And element 115 has actually been synthesized recently in tiny amounts. I think they're up to element 120 now. And a lot of trust the science, bro. We're like, oh, see. He was lying, We made element 115 and it was radioactive. But the thing is, when you get super heavy elements, you can have 40 or more neutrons either way in proportion to the amount of protons. So the amount of protons dictate the identity of the element. And the neutrons are there to kind of buffer and glue the thing together because protons have a positive charge and really don't like to be rammed up next to each other. So, in fact, they want to be repelled. So the neutrons act a bit like glue, and the force that overcomes electrostatic repulsion of the protons that glues all that shit together is the strong nuclear force. And Bob Lazar said that this super heavy element 115 that is stable, a certain isotope, he said it was a pure isotope. It had to be synthesized by an alien intelligence. And he said, we don't understand the physics, but basically gravity as we understand it or don't understand it is actually a shadow weaker version of the strong nuclear force. And the best analogy I have for what he's trying to say is magnetism. So ferromagnetic metals like iron, if you take up a lump of iron, it's not magnetic by itself. And then, if you put electric current through it, or that's how you do it, it suddenly becomes magnetic. What's going on? Well, the actual electrons in the outer shells of the iron atoms and other ferromagnetic metals, they have what's called spin. So spin's basically a like a little mini magnet. They have like a pole. They're spinning, but they're not spinning like a little bead. They're actually, it takes 2 rotations for them to complete one spin because the quantum world's bananas. I can actually demonstrate how it's possible. If you take an object with ribbons dragging around it, you can actually get it to spin twice without the ribbons tangling. So it is possible. It's just really weird. And electrons usually pair up. So the spin of one electron is opposite to the spin of the other and cancels out. Electrons like pairing up like that. And iron is quirky. It has 2 or 3, I think, 3 unpaired electrons in the outer shell that act like little magnets. But in a lump of regular iron, all those little magnets are pointing in random directions, so there's no overall magnetic field. But if you do line them up, then suddenly you get a powerful magnet. Well, Bob Lazar said something is similar with the strong nuclear force in these super heavy elements, because a super heavy element has such a big nucleus that the strong nuclear force is actually closer to the surface of the rest of the atom. So you got a whole swarm of electrons orbiting quite close to the core and a massive nucleus. And if you get a bunch of other atoms, presumably a metal, in a crystalline structure, well, if you can, if what Bob Lazar is saying is true, then the strong nuclear force has something akin to spin, and that creates gravity. And gravity, as we know, is like a very weak mirage of like it's a manifestation of the same thing, but in an extremely weak way. Presumably, I know the spins line up at just enough to make a bit of gravity, but if you can line them up artificially, and this is way outside of physics, then you've got fucking anti-gravity drive. And Bob Lazar said that the alien warp drive thing he worked on in the desert in Nevada ran on a super heavy element that was capable of warping gravity. And now this guy is talking about a scientist that looked at a star in Australia with just regular old astronomical instruments and made measurements that nobody has debunked or refuted, that is seeming to indicate that there are transuranium elements in the atmosphere which can't be there unless they're being constantly replenished by presumably aliens, or there is some unknown super heavy element in that star that's decaying down into these transuranium elements, some reservoir of it. Either way, like Carl Sagan famously said that we should look for weird shit in stars' spectra, because that'd be a really good way to get our attention from aliens. So
be more stable but really heavy atoms. We've never seen any of these yet, but the nuclear physicists do keep synthesizing heavier and heavier elements, and seem set to eventually explore this area of the periodic table and confirm the properties of these atoms. But a paper from March 13th by V.A. Zuba and colleagues proposes that such elements might be produced in a certain type of supernova, and that the weirdness of HD 101065 might be the result of the decay of more stable but still radioactive elements located in the island of stability, leading to all of these short-lived, unstable actinides and rare elements.
I mean, if it isn't aliens, and like, let's face it, it's never aliens. There's a famous saying amongst these rational sciencey people who are curious, you know, it's never aliens. But even if it's not aliens, then there is a super heavy element out there, presumably in lumps, because metals tend to form like rocky planets unless they're in a super hot star and they're all like, you know, vaporized. So I mean, if these super heavy elements were shat out of a ridiculous supernova somewhere out there, then presumably they could coalesce from the dust cloud of a supernova remnant into little asteroids of like some weird super heavy metal or whatever that we've never heard of, that's stable or somewhat stable. I mean, that's pretty freaking exciting. A little nugget of this, like an asteroid rich in some hypothetical super heavy element that's stable, could have wandered down like a comet, like, or whatever, and recently crashed into this star and salted the atmosphere right when we're looking at it. That's actually a possibility too. But hey, I really want it to be aliens.
If this is the case, it would be revolutionary for both nuclear physics and chemistry that such elements could exist in nature. But I suspect that this one will be contentious, because conventional thinking has been that these elements are not likely to be present in nature. And a further question would be that if a supernova was responsible, where is all the iron that is normally associated with supernovas? So to explain this star, we must rely on hypothetical elements decaying after being created by a hypothetical mechanism that counterintuitively didn't seem to produce much iron, or that iron is somehow obscured in the star's makeup. Messy indeed. And that leads us into alien origin territory. In 1980, Daniel Whitmore and David Wright, again citations below, advanced a rather extraordinary proposition. They suggested that a civilization using nuclear energy might dump the waste into their star. The problem with this, though, is that it seems unlikely that a civilization with the ability to dump that waste into their star would still be using nuclear fission, but instead would have moved on to fusion. After all, we're getting close to that ourselves, and within 100 years, fission as an energy source seems likely to go obsolete. That takes us to another possibility. In 1966, Sagan and Shklovsky suggested that one way to announce your presence to the universe is to dump a bunch of artificial elements into your star. They might rightly assume that other civilizations in varying stages of advancement would be doing astronomy and actively looking at the spectra of stars.
So yeah, good old Carl Sagan. I mean, he's a little bit of a Neil deGrasse Tyson in a lot of ways in retrospect. You know, a bit of a Tim Flannery type. You know, bit of a Mikao Kaku. You know, that Japanese physicist that's working with the Saudi government to make that glass wall city in the, you know, whatever. But like Carl Sagan, you know, was the man. You know, popularized science, and yeah, he literally came up with this idea. You know, we should look for this.
Rather than blast out huge energy-consuming radio signals, it might be simpler to use the heavy elements to inform others that they are not alone. That doesn't really convey much information, unfortunately, but if it turns out that the island of stability elements cannot be naturally created, then this will be one of the biggest stories in the history of science. In the end, however, it's always safest to assume that a natural explanation will eventually be found, and aliens are a very broad explanation and always the least likely. If you have to bet...
So yeah, this was one of John's earliest videos. I think it's the one that kind of made him go viral. And he did a follow-up. So he sub to John Michael Goldier. He's just amazing. And I sped his voice up because it would have taken forever. But he's got a very soothing voice. It's always interesting. And he has a podcast every Thursday called Event Horizon, where he talks to actual real astronomers, usually young ones, who are quite open-minded and curious. And they come up with all sorts of cool stuff. One week they're talking about looking for alien artifacts on the moon. They're like, well, you know, if aliens ever visit us in the past, they would presumably set up some kind of surveillance base on the far side of the moon and, you know, send scouts down to Earth. Might still be there. Another one said, well, a autonomous craft could have come. And you have to think of life on Earth in terms of time. You know, Earth has had very strong biosignatures detectable by our own technology, or a little bit better, that we have now from a long way away. But, you know, 10,000 years, 5 million years ago, you know, our ancestors were still, you know, walking on their knuckles. The thing is, Earth life signatures have been beaming out into space now for billions of years. Life's been on Earth for billions of years, bacterial life, and photosynthetic life created oxygen, an oxygen-rich atmosphere, which actually killed off a lot of the earlier life. And a 20% oxygen atmosphere and a bunch of other biosignature gases stands out like dog's balls. You know, if you're looking for life with a massive telescope, I don't know, 50 years in advance of our technology, like a super telescope in space, you could spot Earth's biosignatures in its atmosphere from millions of light years away. And, you know, life on Earth is interesting enough and rare enough. We know that now for people to want to come visit us. But as far as we know, they don't have any Bob Lazar warp drives. I mean, I'd like that to be true, but as far as we know, they don't. So, and sending a massive, you know, 300 kilometer long arc spaceship with flesh and blood, organic life for 10,000 years at 10% the speed of light. That's possible, but far more likely now that we have AI advancing so quick is that you're going to create an artificial intelligence to go scout. And in that case, you literally send the craft out as fast as you can, 10% the speed of light, and put up the shields, and the AI goes dormant, goes to sleep. Time doesn't exist then. And then when it wakes up, it's coming into the Earth's solar system, and, you know, it having spotted Earth's life signatures from a long way away, and presumably needs to land somewhere close to Earth, and using advanced alien technology, build, you know, repair itself from the long journey, build little scout robots to come look at Earth. In fact, I've had a sneaking suspicion that a lot of UFOs and the little grey aliens, they don't look very, they look quite fragile, and they could be some kind of organic robot drone type thing, because actual aliens from a different biosphere, first of all, the resources to travel through space to get here is obscene. But if you have an artificial superintelligence with genetic engineering, then you can land on the moon, send a robotic scout down to take biological samples and make little drones. And the reason you would do that is life is very, very efficient. If you can engineer a biological entity compatible with Earth's biosphere, well, then you've got a automaton drone that you just need to feed biological food, which is also abundant. It's far easier to grow little grey aliens to scout Earth and watch us in little fragile UFOs that are built on the moon than it is to build actual robots. Because, you know, think about if you're going to build an intricate robot from the moon, you need to maintain it, you need to repair it. It's going to be vulnerable to electrical interference and so forth. But yeah, the little grey aliens seem to be very fragile to me, and their craft are apparently easier to take down than was first thought. The Roswell crash in 1947 was apparently two of these craft hitting each other, and Nikola Tesla and Einstein were working together post-war, and everything they did together is still classified above top secret, but apparently they set up some kind of energy field that interfered with these craft and took two of them down. Hey, there's a lot more folklore where that came from. I love sliding from actual science with a weird style like this to UFO folklore. Anyway, I hope you enjoyed it.